Okay, so on this question, manufacturer has been selling 1,700 television sets a week at $540 each. They're going to ask us about price function here. A market survey indicates that for each $18 rebate offered to a buyer, the number of sets sold will increase by 180 per week. So if they say we're going to give you an $18 rebate, they're going to sell 180 more sets per week. Of course, they'll get a little bit lower price. So then if they lower it by 18 more, so $36, 18 twice, they'll increase by 180 twice, etc. Every time they lower the price 18 bucks, give an $18 rebate, the number of sets goes up by 180 that they sell. So let's find the price function where X is the number of television sets sold per week. So I want to get a relationship here. Basically, this is your Y. Remember, because function values are Y values. So what I'm going to do is notice that we've got 2 points. X is the number of television sets sold. So X1, Y1, or we'll call it P1. Okay, so say, 1,700 television sets are sold when the price is $540. That's X1, P1. And then if you give an $18 rebate, so if you subtract $18 from the price, would that be 25.22? You lower the price down to 522, right? You $18 rebate back. You'll sell how many more sets? 180 more sets. So it'll be up to what's that? It's 180. So 1880. That's X2 P2. See how I came up with that? So I've got X1 P1, I've got X2 P2. Got a couple of points. So I want to find the equation. This is a linear relationship because, every time you go $18 down in the price, you go up 180 sets sold. That's straight linear relationship. So how do you find that? Well, you got to find the slope. What is slope? Remember the equation for slope? It is y2 minus y1 over x2 minus x1. And remember, P price is our y value here. So, all right, so what do we got? P2, here is P2, P1. So 522 minus 540 over x2 minus x1. 1880 minus 1700. Okay, let's simplify that. It's minus 18 over 180. And we really could have guessed about that. $18 rebate, down $18 in the price, 180 plus 180 sold, more sold. That's the slope. That's the linear relationship. Okay. So now we could reduce that. Yeah, I mean, let's do that. Let's reduce that. Let's divide top and bottom by 9 just to make that easier. Minus 2. Oh, no, 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 just by 10, huh? Yeah. Oh, yeah. Or by 18. What am I doing? I'm being goofy. By 18. Top and bottom. That's minus 1/10. Yeah. All right, so now we have y equals mx plus b, and we know the m is minus 1/10. Okay, so trying to get the equation. The y again is p, so let me just put in p here. P is price. Okay, now what do you do now? Just plug in either the first point or the second. So I'll plug in 1,700 for x and the price 540. You could have plugged in the other point. It doesn't matter. So 540 is minus 1/10 times 1,700 plus b. And now I can solve for b. So 540, multiply that in your calculator, minus 170 plus b. Add the 170 to both sides. And what's that going to be? 6, 710. B is 710. So our formula then is y equals mx plus b. Y is p. Price m we already knew was minus 1/10. And our b now we know is 7/10. A little scribbly there. 7/10. There we go. Minus 1/10 x plus 7/10. Minus 1/10 x plus 7/10. We found the linear relationship between price and number sold. And so that's what you would use then. So we're just doing part one. This is just setup. Normally, then we would take the derivative, set it equal to 0, find the price to maximize total revenue or profit or something like that. And so that's all we're going to do on this one. There we go.